Alright guys, welcome back. It is Desoldering with you today, and I have an awesome tool to show you today and right now. It's a hot air gun that you can use to desolder SMD components. Really useful tool to have in a lab. Yeah, it's just so cool. So let's get started. But before we do that, I want to remind you that if you're a new guy here, please subscribe to my channel. It really means a lot to me. Let's get started. Alright, ladies and gents, welcome back to the lab, and we have another suspect here, as I promised in the previous video, about my big Bertha. If you hadn't seen that video, check it out. I mean, it can't get more crazy than this. Like, I don't know what it would be equivalent as. A 500 watt soldering iron or something. It's just insane. Works really well. And you can build it with basic tools. If you had troubles desoldering something because your iron is too weak, that would be the way. Anyway, watch that video down here. So, this is a heat gun that I bought off eBay. Now, I was actually going to make a review of this thing, or sort of, and take it apart. Now, the problem was I didn't know what to tell you. Was it any good? Is it robust? I don't know. So I decided to use it for a couple of days. So, I used it for a couple of days, and I have my opinion on this thing. Is it good? Is it bad? I'm actually going to say it's not good, but it's decent enough to have laying around on the table for occasional jobs. It's just perfect for heat shrinks. It can't get any better. I mean, it gets the job so good done. It just works too well, actually, for heat shrink. For desoldering components, well, that is something that is debatable depending on what you are trying to desolder, obviously. And I will be demonstrating that in a minute or two. But let's actually talk about a build quality. So, obviously, first impressions when you hold this thing in hand. By the way, if you're wondering, this thing costs 55, I think, Canadian dollars, which would be about 43 or something USD. So it feels cheap in the hand. Okay, it doesn't make any weird sounds when you twist it, obviously. The cord is nice. I was actually surprised about the cord. The cord claims to be 200 volts. No, actually 500, sorry. And it doesn't have a temperature rating on it for some reason. The controls, though. The controls feel cheap. You can feel the brushes on the potentiometers actually scraping on there, and I don't know, one is tougher to turn than the other one. I don't know if it was intentional or not, but yeah. So here we have a model number, and then Gonju whatever, 200 watts rated, 110 volts. Why 110? I don't know. North America, we have an RMS voltage of officially 120. In reality, about 119.5, but 110. Go figure. That's the old standard, actually. So the heater. I don't know. I think it's ceramic. I do see some ceramic elements in there, so it must be good. How long it will last? No idea. So let's actually power this thing up, and I will show you what it does. So, what do we have? We have a switch here. We have an LCD screen. We got two knobs. We got an LED. For some reason, this sticker is upwards and air and heater is downwards. Yeah, go figure. Chinese, what can you say? So, that actually loosened, but that doesn't matter. So, you turn it on. The thing makes a weird sound, as you hear right now. It's actually amplified by the table, but it makes a weird sound. So the first time I turned it on, I thought it must be bad motor or whatever. Now, what I read on the package is that it actually uses a special pump, a special air pump. Now, the way that pump works is you have a motor which has a crankshaft on it, which is pushing a membrane back and forth, which is the same air compressor or air pump that a fish tank uses. It's vibrating a lot, but it has pressure to push it. So this claims to use the same type of pump. I'm not sure. I will be taking this apart in the next video, and we will be taking a look at how this thing is made inside. But when you increase the thing, makes a pretty decent sound. Now the heater is off. I can touch it right now. As you see, the temperature is 26 degrees, but that's ain't for too long, my friends, because when you crank up the heater, this thing goes really fast. So the air is now hotter than I can touch, so it's getting really hot. Now if you take a peek inside, you might be able to see it's glowing red hot inside. Now you can't see it, but trust me, it's glowing red hot. So we are going to let this thing heat up while I get a motherboard. Alright, let's actually try to desolder something. Now there will be no close-ups, but I will be desoldering this, probably a BIOS chip right here. As you can see, I can't lift it. Okay, it's soldered on there, no tricks. I want to be this as honest as possible, so please follow this chip. I won't be cutting anything out. I just want you guys to see how long it takes to desolder something with this thing. So I'm heating up the motherboard, alright? Now we shouldn't really damage the chip whatsoever, because the temperature is about the same as when it goes into the oven where the motherboard is made, so shouldn't really harm that. So trying to lift it, you see I'm lifting the motherboard, it's still dead. Let's try it again. Boom. Here we go. You lifted a chip. Here we go. Alright, so we had desoldered the chip. Now, this device would be practically useless if we were not able to put it back. So I will try my best to actually solder it back. So what I want to do is we will heat up the pads to melt them, and Then I will apply some flux. Then we'll put the chip on top. So what I will do is, we have this socket here, well, not really a socket, but 8 pins. So I will take my tweezers, I will apply a tiny little bit of flux. Now the flux is only to take the oxidation off the solder, which will help the chip to get on there and actually stick better, I guess. Not a whole lot. You can always wipe that off, like once you're done. You can easily use alcohol, wash the whole board in alcohol, and it will clean off this flux. So while I wait for the heat gun to actually turn on, it seems to have a temperature switch in there, so when it overheats over 760, I think, on the screen, it will shut off. So alright, it's back on there. I don't really want to move it because it might fall off again. But as you can see, that chip is soldered. So that is that. Really cheap device for the money, I think. And it gets the job done. So guys, that is it for this video. I hope you enjoyed this one. It's quite a cool device to have in your lab. It can do pretty much anything from soldering to shrinking, heat shrink, heating things up. I mean, it's just so versatile and so good. And in the next video we will be tearing that down, so I hope you watch that one. I'll see you there.